If you roll a ball, the friction opposes the movement of the ball between the ball and the floor. Same stone is being pushed by two persons but in opposite direction. What will happen? The net force will be 0. The velocity was same. It was 50 km per hour. What was the change? It was the mass. Hello students. Welcome to this first session on Chapter 4, Laws of Motion from first PUC Physics. I am Madhu R from the Department of Physics at Vidhyaashram PU College, Mysuru, your temple of excellence. Since we are learning laws of motion, let us first get into understanding what is motion. Okay? Sir Isaac Newton used Galileo's idea of motion of an object to frame the laws of motion. Motion basically refers to changing of position with respect to time. I am here now. After a few seconds, I'll be in this position. So this change of position from position A to position B can be called as motion. Motion of the object needs the concept of velocity and acceleration. To better understand motion, we need to understand velocity as well as acceleration. But let us first understand what are the types of motion that are known to us. Vibratory motion. Okay? Attach a string to two pillars, then pluck it once. The up and down motion of the string is called as vibratory motion. You push a box across a floor, it is called as linear motion. You kick a ball across a curved slope, it is called as curvilinear motion. Okay? You take the example of a pendulum that oscillates from one end to the other, it is called as oscillatory motion. You make a motion in the form of a circle. Okay, you take an aeroplane and circulate around the earth once. It is called as circular motion. You take the example of a fan which rotates with its axis fixed. It is called as rotary motion. So these are few of the famous motions that are known to us in general life. Let us go ahead and check what was Aristotle's law. Please remember, Aristotle was a man who lived in 3rd century BC. Okay. He had a statement which said that an external force is required to keep a body in motion. So you always require a force to keep a body in motion. If you just roll a ball along a ground, he felt that you should keep on rolling the ball, otherwise it will stop. This understanding was wrong because he couldn't understand what was gravitation or what was friction. That is called as fallacy. Okay? Fallacy is basically misconception or misunderstanding of a concept. What was the fallacy in the law? A moving object comes to rest because the external force of friction on the object by the floor opposes its movement. If you roll a ball, the friction opposes the movement of the ball between the ball and the floor. If there is no friction, no force is required to keep the ball in motion. Okay? So, that is why we say that Aristotle's law was a fallacy, misunderstanding. He couldn't understand the concept of friction in 3rd century BC. Okay? Moving on. Let us check what was the further development. We come to a point called as inertia or resistance to change. Early morning, my alarm gives me a buzzer. Okay? I feel that there is an opposition to get up. This is basically inertia. Okay? So, inertia is the property of a body by virtue of which it tries to remain in its state of rest or motion. I was asleep. I was sleeping on the bed. I prefer to be sleeping on the bed itself. I don't prefer to get up and get going. Okay? So, that is basically inertia. So, what is inertia? The body prefers to stay in the state of rest or in the state of uniform motion unless an external force acts on it. This is called as inertia. Okay. What is the example? A mass is a measure of inertia of a body. You have to lift a balloon. Very easy. Simply you can lift it up. Now imagine lifting a shot put. Okay. Or a gas cylinder which is some 35 kg. It takes a lot of effort. It requires a lot of force to lift it. So mass is a measure of the inertia. The more mass it has, a body has, the more inertia that will appear so that it opposes the movement or it opposes the rest state. Types of inertia. There are three ways in which we can try to understand what is inertia. Inertia of rest, inertia of motion, and inertia of direction. What is inertia of rest? Let us try to understand this with the help of an example. I am sitting in the back seat of a two-wheeler or a car. It has not yet started. It is at a state of rest. Some driver comes in, he starts the car, he suddenly gives the accelerator. What will happen? I had to be in a state of rest. As soon as the car moves, my body will go back, it will swivel back and then it will come forward. Means the body wanted to be at that backward position itself. That is inertia of rest. The property of a body to remain at rest is called as inertia of rest. The best example, vehicle moves suddenly from rest. Okay. Next type of inertia, inertia of motion. Now, I am sitting in the same back seat of the same vehicle, two-wheeler or four-wheeler. He is traveling at some 60 or 80 kilometers per hour. Somebody comes suddenly in between the road at a distance of 50 to 100 meters. Okay, he observes that person, suddenly applies the brake. Now you are moving forward, but since the brake is applied, you will go forward. You wanted to stay moving forward. Okay, you did not want to be at rest. So the body now goes forward when the brake is applied. The property of a body to oppose the change in motion is called as inertia of motion. Best example, braking of a vehicle suddenly at high speed. Now the third type of inertia, inertia of, if you roll a ball, the friction opposes the movement of the ball between the ball and the floor. Suddenly makes a turn either leftwards or rightwards at high speed. At that 60 or 80 km per hour itself, it turns the car. What will happen? If the car is turned to the left, my body will swivel to the right. If the car is turned to the right, my body will swivel to the left. It wanted to stay in the same position, same direction. Okay. So the property of a body to oppose the change in its path of travel is called as inertia of direction. The best example is a car turns suddenly at high speed. So we have understood what was inertia and what are the types of inertia. Why this is important? This frames the background or the foundation for Newton's first law of motion. Okay. So let us come to Newton's laws of motion. Newton's first law of motion is also called as law of inertia. That is why we have brought in the concept of inertia before the first law of Newton's motion. What does it say? Every body will continue to be in its state of rest or uniform motion along a straight line unless compelled by an external force to act otherwise. So if you don't stop a ball from moving, it will keep on moving in a straight line. If the ball is stationary on a table, it will not move until you push the ball to move. This is the best example to understand Newton's first law of motion. You can understand here. What is to be understood? What is an external force? Two people are pushing in the same direction. This stone can be moved forward. Same stone is being pushed by two persons but in opposite direction. What will happen? The net force will be zero. The net force acting will be zero. This person is pushing the stone, say by 50 newtons towards the right. This person is also pushing the stone by 50 newtons in the left direction. What will happen? It will equate the net force is zero. So the stone will be stationary. Okay. You can understand by taking the example of a stationary ball. Unless someone kicks it, it will not move. You can also take the example of a moving ball. Someone has already kicked the ball. Unless someone stops it, okay, unless a net stops it, this ball will not stop moving. It will be in a state of motion itself. Okay. Now there is an alternate statement to this first law of motion. What is that alternate statement? The first law can be stated in terms of acceleration. How? If the net external force on a body is zero, okay, if there is no external force, its acceleration will also be zero. See here, the net external force is zero, acceleration is also zero. Or in other words, acceleration can be non-zero only if there is some net external force on the body. If there is some net external force on the body, then this stone will travel with some acceleration which is not 0. Okay? What is the significance? What is the importance of this Newton's first law of motion? Newton's first law of motion gives the definition for force and reveals what is inertia. So our definition of force comes from this Newton's first law of motion. It also lets us understand what is inertia. So once we said that, it lets us understand what is force. Let us check what is force. Force is any push or pull that causes an object with some mass to change its velocity or deform in shape. I push a person, okay? There is some change in velocity. If he was stationary, standing still, he will move further. If he was already moving and you push him, okay, his speed will increase. If you push him in the opposite direction, then his speed will decrease. Overall, there will be some change in velocity. Or if it is not change in velocity, there will be some change in the shape. It will deform. Okay? Force is a vector. It is having the same direction as that of acceleration. Okay? Force has the same direction as that of acceleration. What is the vector form of force? Force is given by mass into acceleration. The SI unit of force is Newton. Dimensional formula for force is mLT to the power minus 2. Okay? What is 1 Newton of force then? 1 Newton is that force which causes an acceleration of 1 meter per second square to a body of mass 1 kg. When you have a body of mass 1 kg, it can be accelerated by 1 meter per second square when the force acted upon it is 1 Newton. Okay? So that is the definition of force and how you can try to understand that force. Let us come to another interesting topic which is called as momentum. In this case, we will study about linear momentum. Okay? We will come to angular momentum at a later point of time. Let us try to understand what is momentum or linear momentum. Momentum is the product of mass and velocity. Mass into velocity will give you momentum. In vector form, momentum is represented by this P along with the arrowhead is equal to mass into velocity. The SI unit of momentum is kg meter per second and the dimensional formula is mLT to the power minus 1. Momentum being a vector quantity will have the same direction as that of velocity. It is a measure of that ability of a body to impart motion to another body. Please observe that definition. It says ability of a body to impart motion to another body. A football is coming near you, you give a header and give it some direction. Ability of this body to give a motion to this ball. It is called as momentum. Okay? Let us try to understand few more importance of momentum with an example. How important the concept of momentum is. Imagine that a bicycle and a truck, okay, a bicycle and a truck are traveling with the same velocity. They may be traveling at say 50 km per hour. Now God forbid, if the bicycle hits you and if the truck hits you, what will be the impact of these two collisions? Obviously, the cycle hitting you will cause some minor damages, whereas the truck hitting you will cause some fatalities. Okay? It's a very, very huge damage that will be caused. Why? Because the bicycle may be around 30 kg max, okay? Whereas the truck will be 3 or 4 ton. An empty truck will be 3 or 4 ton. If it is filled up, it may go up to 20 ton. Okay? Please remember, momentum is the product of mass into velocity. The velocity was same. It was 50 km per hour. What was the change? It was the mass. So when the mass is more, the damage will be more in case of a collision. Okay. Now let us take the opposite example and try to understand the same. The same truck is coming, the same bicycle is coming. Bicycle is traveling at 50 km per hour, whereas the truck is traveling at 1 km per hour. Now the effect of collision of the bicycle is greater because the velocity is 50 km per hour, whereas the impact of the truck is far lesser because it is traveling at 1 km per hour. See, you understand the impact of mass and velocity in momentum. Okay. Now let us move on and go to Newton's second law of motion. What does this say? The rate of change of momentum of a body. Okay. How does the momentum change with respect to time? That is rate of change of momentum. Okay. The rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of the force. Okay. So this force is directly proportional to change in momentum with respect to time. And what will be the effect of this momentum? If the force was acting in this direction, momentum will also act in the same direction. You can observe there, a person is pulling a cart of mass m with an acceleration a. He has to apply a force F. Now two men have joined together to pull the same cart. What will happen? The acceleration increases by 2a because the force applied is 2F. Okay, two forces are being acting, so the acceleration increases by 2a. Now the same single person is pulling the cart. What happens? The mass has increased. It has doubled. So what will happen? The force remains at F, but the mass is 2m now. So the accelerations becomes a by 2. So the truck will be pulled, the cart will be pulled, but at half of the acceleration. Okay. So that is what the second law of Newton says. The rate of change of momentum of a body is directly proportional to the applied force. It also takes place in the direction of force. The man is pulling the cart is moving in the same direction. Okay. Now let us try to derive an equation for force. Okay. Consider a body of mass m moving with a velocity v1. So when a body is having mass and moving with a velocity v1, it will have momentum. Let us call it as p1. Okay. Consider a body of mass m moving with a velocity v1 and having a momentum p1. Let a force F act on it for a time delta t. Okay. So one force is acting on it for a time delta t. Once a force is applied along with this, the momentum will change. There will be a change in momentum. So the velocity changes to v2 and the momentum changes to p2. Okay. So this is p2 is equal to m into v2. The change in momentum is given by p2 minus p1 is equal to mv2 minus mv1. Okay. Change in momentum is given by dp m into v2 minus v1. Instead of v2 minus v1, I am using the vector form or the derivative of velocity dv. Okay. From the second law of motion, I know that F is equal to k into dp by dt. Please remember, second law of motion says that force is proportional to rate of change of momentum with respect to time dp by dt. So instead of using a proportionality symbol, we have equated it with the help of a constant k. Okay. So F is equal to k into, what do we have for dp? M into dv by dt. Please remember, what is the rate of change of velocity with respect to time? Rate of change of velocity with respect to time gives me acceleration. Okay. So instead of this dv by dt, I will use it as a. Force is equal to constant into mass into acceleration. For simplicity or for ease of mathematics, let us keep k is equal to 1. Then Force is given by product of mass and acceleration. So F is equal to m into a is the popular equation that we shall be using. Okay. Now, let us try to understand a new concept called as impulsive force. What is this impulsive force? It is a large force. The force is huge in nature, acting on a body for a short interval of time. Okay. Force is large, interval of time is very small. This is called as impulsive force. What is the example? The batsman hitting a ball. What is the time of impact? The ball touches the bat for a microsecond. But if he has timed it properly, it can go out of the stadium. Similarly, a tennis person making a serve. The serve can go up to a speed of 230 or 240 km per hour. He doesn't keep hitting the ball for 5 seconds. There is only a small interval of time. Okay, a short interval of time where a large force is acting. So that is the typical example of impulsive force. What is impulsive force? It is the product of force and time for which the impulsive force acts. It is also known by the name impulse. Impulse is represented by capital J. It is given by force into time. What is the unit? The unit is Newton second. Okay. So this is about impulse and impulsive force. How to reduce the impulsive force? A cricket player lowers his hands while catching the cricket ball. If you have your hands higher up in the air, it will hit you harder. If you just take it downwards, it will hit you with a lower force. Vehicles are provided with shock absorbers. So whenever there is a imperfection on the road, okay, it will not affect the passengers seated inside. That is why you use shock absorbers and springs. Okay, those are few examples to understand what is impulse and what is impulsive force. Let us now come to what is called as impulse momentum theorem. Impulse of a force is given by change in momentum of the body. This is what the theorem says. Impulse of a force is equal to change in momentum of a body. Now impulse we know is J is equal to F into T. Impulse is given by capital J. It is force into a small interval of time T. Okay. But we also understand that force is equal to mass into acceleration. Okay. So what is impulse now? Impulse is equal to mass into acceleration into time. Go back to kinematic equations. V minus V naught is AC. V is equal to V naught plus AT. I am moving this V naught towards the left side. So I get V minus V naught as AT. So I replace this AT by V minus V naught. So I am left with mv minus mv naught, where V is the final velocity, V naught is the initial velocity. What is momentum? Momentum equals mass into velocity. Okay. So I have impulse is equal to final momentum for this final velocity and initial momentum for this initial velocity. Or in other words, impulse is equal to change in momentum. Okay. This is what the impulse momentum theorem states. What does it state? I repeat, impulse is equal to change in momentum. Okay. Let us now come to understand what is Newton's third law of motion. Okay. A very popular one. We have all studied this even in our high school physics. For every action, there is always an equal and opposite reaction. For every action you make, there is always an equal and opposite reaction. If there is a force AB that you are applying on the floor while walking, with whatever force you push the floor back, the floor will push you forward with the same amount of force. Okay. What is the best example to understand? Okay, you are towing a boat. Whatever force with which you push the water backwards, the water will push the boat in the opposite direction, in the front direction. Okay. Let us take a few more examples. Let us take the example of a swimmer. Okay. Whatever force with which the swimmer pushes the water backwards, with the same speed he will be able to travel forward. Similarly, whatever is the push by the wings of the bird on the air, with the same velocity, the air will push the bird upwards. Okay, the flapping of the wings, how fast it is, with the same velocity, the bird can move upwards. Few more examples we'll try to understand. Firing of a bullet. Okay, when the gun is fired, the bullet is pushed forward. Okay, the gun will recoil and hit you back with the same force as the bullet is pushed forward. Similarly, whatever force is applied by the rocket to push the ground, okay, the same amount of force will be acted upon the rocket to push it upward into the sky or orbit. Okay, so these are few of the examples to try and understand what is Newton's third law of motion, which says that for every action there is always an equal and opposite reaction. Have a wonderful learning experience. Thank you.